Our system that we are using is like a ScanStation P20 and the related system. It's practically the state-of-the-art in mid-range scanners. It has some impressive specification, for example, scanning rate or acquisition rate of 1 million points per second. So it works very quickly and it reduces the costs of field work. It is also very accurate, so 6 millimeters at 100 meter distance or range. The range is medium range, so from 0.4 to 120 meters. And what is also interesting is very small beam diameter, which allows for very high resolution. So with this beam diameter at 2.5 millimeters at 10 meters, at 10 meters range, we can achieve, I would say, 5 millimeter resolution at 10 or to 15 meters easily. There are a lot of limitations, of course, and one of the limitations is related to the working conditions. It is sensitive to any kind of noise, including rain, traffic, fog, vegetation, and so on. But there are advanced filtering methods which can be used to avoid and overcome such problems. The other shortcomings is relatively expensive maintenance and relatively expensive software. So basically you need several software solutions just to work on the raw data and to start analyzing point clouds on a higher level, so on application level, like in engineering geology. You also have some other solutions which are not so costly, and even some of them are open source. So the community is growing and application is growing, which means that we can expect further improvements in this sense. So the case study is located in Serbia, as you can see, relatively close to the capital of Belgrade, near town of Ljig, on a high road named M22. Which is relatively, it has relatively heavy traffic there, and it is one of the most dangerous road paths in Serbia. Some parts are very dangerous, and one example is this curve here, and this is our case study. The slope here is our case study. Of course, the danger comes from the slope itself, from the rockfall from the slope. But also inconsiderate driving. In terms of geology, it is relatively simple geological setting here. We have a single rock mass characterized as Upper Cretaceous Flysch Formation, but it contains alternating units of sandstone, conglomerate, and shale. Which means that we have different mechanical properties within the formation, and which is why the modeling would be tricky, and this is what awaits us. This is not the scope of today's presentation, but it is there in the future. It is somewhat textonized. You can maybe see these marks here. It is practically a monocline form which dips towards the north. And there are no significant fault lines in vicinity of this area. We discovered 3 discontinuity sets that are important, including bedding and some conjugated joint systems. And based on some engineering works in vicinity, we adopted friction angles between 20 and 30 degrees for our analysis. So this is how it looks like. On the site. First, scanning epoch was in 2011, which was a bit. There were some problems with the battery, so it wasn't our equipment, and the problem was that the scanning was stopped from the single point, and we have only half a slope scanned at sufficient resolution. So this is why we decided to find a pilot area inside the slope to monitor and analyze as a pilot area.